Welcome to EDU World Space.
Problem 3.82. In this problem, we have to find equivalent force couple system because of this 560 pound force acting at point C at point A and B. So first we are going to calculate equivalent force couple system about point A. So we can do one thing, that we can resolve this 160 pound force into its horizontal and vertical component. And since there is only one force is acting on this system, that's why the equivalent force at this point A will be the force that is acting at point C. So if we talk about its components in horizontal and vertical plane, it will be 560 cos 20, and here vertical component will be 560 sin 20. So the equivalent force at point A can be written as 560 cos 20. Alright, we haven't defined the coordinate axis here. Let's say this direction is x-axis and this direction is y-axis. So 560 cos 20 I cap, and in vertical direction it will be minus 560 sin 20 j cap. Now force vector is known. To calculate moment, equivalent moment about point A, that will be position vector of point C with respect to A multiplied with r vector. All these are vector quantities. Now position vector is known. Now force vector is known. If we calculate the position vector, so we need to define an origin. And so let's say this is our origin, and so coordinate of C will be, since this entire length AC is 18 feet, so its horizontal distance will be 18 cos 30 and vertical distance will be 18 sin 30. So we can directly write the position vector of point C with respect to A, that will be 18 cos 30 I cap plus 80 sin 30 j cap. So this was the position vector of point C with respect to A, and we can multiply this with the force vector that we have calculated here, that is 560 cos 20 I cap plus 560 sin 20 j cap. We can solve this by using determinant method. This is I, this is j, and k. Its position vector is 18 cos 30, j cap is 18 sin 30, and k cap is 0. And here it is 560 cos 20. This is 560 sin 20, and this component is 0. Alright, we have made a mistake here, that this force component is in negative direction. Since here it is negative sign, so we will use minus 560 sin 20. So here also it will be minus 560 sin 20. Now we can expand. If we expand about x, both the component will be 0. If we again expand about j component, so it will also be 0, since 180 cos 20 is going to multiply with 0, and this 0 will multiply with this element. So the only component of this moment vector will be along k cap, and its coefficient will be 80 cos 30 multiplied with minus 560 sin 20 minus 560 cos 20 multiplied with 18 sin 30. If we solve these values, this comes out to be minus 7721.637 fit k cap. So this is the equivalent moment that will act at point A, and this will be the equivalent force that will act point A. Now in second part, we have to calculate the same thing, but for the point B. So again we can make the same argument, that whatever forces are acting at point C, since there is only one force acting on the system, that's why the equivalent force at point B will be the same that is acting at point C. So equivalent force at point C, we can write it as equivalent force at point A. So equivalent force at point C will be again the same, that is 560 cos 20 I cap minus 560 sin 20 j cap. Now, for the calculation of moment vector, this force vector is already known, but now we have to change this position vector of point C with respect to A. Instead of this, we would have to use the position vector of C with respect to point B. So we would have to define the position vector as this length is BC length is 10 feet and this angle will be 30 degree. So its component along x-axis will be 10 cos 30 and along y-axis will be 10 sin 30. So we can write here for the moment about point C will be position vector of point C with respect to point B multiplied with a position vector multiplied with reaction at point C or equivalent force at point C. Now the position vector of point C with respect to B is 10 cos 30 I cap plus 10 sin 30 j cap. This will be cross product with force, that is 560 cos 20 I cap minus 560 sin 20 j cap. So if we can solve this by using determinant I cap, j cap, k cap, here the I cap component of the position vector is 10 cos 30, j cap is 10 sin 30 and k cap is 0, and for the forces this is 560 cos 20, this is 560 sin 20 and this component is 0. If we expand along I cap and j cap, both the coefficient comes to be 0, so the only coefficient comes is about k cap and it will be 10, here will be minus sign, 10 cos 30 multiplied with minus 560 sin 20 minus 560 cos 20 multiplied with 10 sin 30. So we can solve this by using calculator and it comes out to be minus 4289.798 k cap. So this is the equivalent moment about point B, and equivalent force about point B will be the same, that is acting at point C.